So fundamental theorem of calculus. There's two parts to it. We did the first part a while ago. Integral of a derivative. Derivative means slope. Integral means area. Okay. And you don't have to write anything. I printed it on the paper for you because we did this way back when and you did it last year. Integral from a to b, you have a starting point of your f prime. If you do an antiderivative from f prime, that takes you back to just f, and then you do upper boundary minus lower boundary. Cool? Yeah. All right. Now we're going to do part two. Derivative of an integral. It's the rate at which your area is changing. See, d dx, that is instructions that mean take a derivative with respect to x, okay? This means take a derivative with respect to x. So looking at this part, if you did integral from a to b of some sort of function, you would get a numeric answer. This would be a constant. You would end up with some number, right? Like you would do the antiderivative, you would do upper minus lower, and you would get 5 or 17 or negative 12 or whatever, okay? Now, if you do the derivative of a constant, what are you going to get? 0, nothing. So if both of your boundaries are just plain old numbers, then your antiderivative is going to give you a number, and when you do the derivative of just a constant, you're going to get 0. Also, is there an x in there anywhere? No. Okay. So look at this one. Derivative with respect to x. Now there's an x. Okay. A derivative and an integral undo each other. They are inverses. I will allow you to say cancels out. It's fine because I'm not picky about that. But they undo each other because they're inverses. So essentially, all you're going to do is take this x and plug it in to the function. So instead of f of t, it's going to be f of x. You're not going to put plus c. You're not going to put anything. Basically, the only way you can mess it up is if you do anything. Okay? Derivative and integral cancel out. Basically, the only way you can mess it up is if you do anything. You're just going to take that x and plug it in. Can I finish the last one? Because I may end up answering your question. Okay? Now this one, instead of just plain old x, it's an actual function. Now here I wrote g of x, but it could be x squared or 2x cubed or square root of x or sine of x. Do you get what I'm saying? Like more than just x? What derivative rule is that if it's more than just x? There's a chain rule. Okay, so what you're going to do is take this g of x and plug it in, same way we did this one. So it's going to be f of g of x, and then you're going to chain on the derivative of g of x. So times g prime. Okay? So you just take whatever that upper boundary is, plug it in, and if it's more than just x, then you have a chain rule, okay? If the boundaries are swapped, what do you think you're take two. What do you think you're going to need to put in front if the boundaries are swapped? A negative.
Why are we not using A?
That is a good question. Why are we not using a? Because a is constant, and the derivative of a constant is 0. So if you were doing that part, you would just have minus 0 at the end of everything. And so we just don't write it. It's kind of like there's always a chain rule, but what's the derivative of just plain x? 1. Are you going to write times 1 times 1 times 1 at the end of every single thing that you write? No, it would be really cluttered with all the ones. So it's there. We're just not going to write it. Yeah, you guys are asking questions before we even do it. Can we just do some problems? Because I think we're going to address that. Okay? You guys are so brilliant that you're like, mentally you've done it already and we didn't even do any questions. Let's just try a few of them, okay? Do you see how this is just 5 to x? I'm going to start with an easy one, all right? 5 is a constant. Ignore that. Literally, all you're going to do is plug x into this, and your answer is x squared plus 4x minus 7. Again, the only way you're going to mess it up is if you do something. Okay, now this one, it is just x, so you're just going to plug x in, but you see how the boundaries are swapped? We're going to need to negate it. You're going to negate the whole thing. So what I would do is set it up blank. Again, I'm a big proponent of set it up blank. All right, negative, and then we're going to give the whole thing a hug, and you're just going to plug x in. So x squared minus x. I figured I might. And if I didn't, then you could just ask it and we would go over. But usually the examples help. All right. Now this one, we're going to plug in 5x. So it's going to be e to the 5x. But what? times 5. I'm going to just go ahead and put that out front. If you put chain rule dot and then a 5, fine. Okay. How about this one? Why is it 0? Constant. Derivative of a constant is 0. All right. For this one, you're going to plug in the x cubed. So it's going to be cosine x cubed. You can put parentheses around it if you want. Chain rule. You're going to chain on the derivative of x cubed, which is 3x squared. I just wrote it out front. You could put a little dot and put it at the end. That's fine. Whatever. You do you. Cool. It's personal preference. It's not like I'm right and you're wrong or vice versa. Like I get people at your level that are super brilliant that want to argue my way is better. So I always like to say that there's not a way that's better and a way that's worse. We can both be right. We can both be wrong too, but let's both try to be right. So for this one, couple of things. We're going to put, yeah, do you say your feelings are valid to people? Because I just want to validate your feelings. You're allowed to feel frustrated or sad or upset. You still have to do this, but your feelings are valid. All right, we're first going to plug in the x squared. So if you do x squared squared, it's x to the 4th, and then plus 5x squared. Okay, so step 1, we just plugged in the x squared. Second thing, though, I do need a negative, and I left a little gap because there's actually a third thing. Chain rule, the derivative of x squared is 2x. I just wanted to finish my thought, but go ahead. Or did I answer your question? Or did you just have a comment? Oh, yeah, did you want... Oh, you're okay, perfect. Yep, everybody's just sort of, we're just kind of having a conversation, which is the way I like for it to go. All right, for this one, what do you notice on that? They're both variables, okay? We're going to do upper minus lower. Okay, just going to be a little bit of algebra. So you're going to have 2 times x plus 3 minus 5. So I plugged in the upper boundary, and the good news is we don't have a chain rule because the derivative of x plus 3 is 1, and then the derivative of x is 1. In fact, I've never seen one where there would be, so just don't even worry about that. All right, minus, so that was upper boundary, minus lower boundary, you're just going to plug in x, 2x minus 5. I just put a few extra hugs there so you could see it. I threw some extra parentheses, all right? Welcome back to Algebra 1. What are we going to do here? All right, distribute. That'll be 2x plus 6 minus 5. No, 2 times 3 is just 6. Yeah, there's not like another t there, right? And then we're going to distribute the negative, so it'll be minus 2x plus 5. And then when this happens, because they both had an x, a lot of stuff is going to cancel. So what all goes away here? Yeah, well said. Everything except for the 6. So you just end up with 6, which is cool. Yay. All right, and then this last one. When they throw a whole lot of information at you like this, and symbols and notation and all these letters, and you're like, I long for the day when math was just numbers. What you need to do is go, what do they want from me? What is the thing that they are asking? Go to the find part. Do you see how this says find f of 6 minus f of 4? That should trigger in your mind integral. It's upper boundary minus lower boundary. So when we set up an integral, it's going to be what to what? 4 to 6. And what is the only thing that could go inside of the integral? Perfect. So you want to go, they can't give you an undoable problem. So you want to go, what did they ask me for? Like work backwards. What do they want from me? And then there's only one other thing that could go in there to set it up. So that's what it has to be. Fundamental theorem. When you see this, you want to think upper boundary minus lower boundary. Fundamental theorem of calculus. All right, and then we're just going to do the problem. Antiderivative of 2t. T squared. Antiderivative of just 1 is 1t. Yeah, good. Such that, there's no plus c because we're going to actually evaluate it. 4 to 6. Upper minus lower. So if we plug in 6, 36 plus 6, 42. Did I add that right? Okay. And then if you plug in 4, you would have 16 plus 4 is 20. So 22. Lovely. No, it's not that. It's never that bad. The hardest thing about calculus, and especially Calc BC, is the symbols and the notation. You're essentially learning another language. You're learning the language of what all these symbols mean. It's like, what on earth do they want from me? And the actual math that you do is 42 minus 20. It's not that hard, okay? All right. This is what is called an accumulation function. And I really love this lesson because it takes everything that we've like learned so far and puts it like all together nice and neat on one piece of paper. It's called an accumulation function. And just as a heads up, what we're going to do with it next time is word problems. So you're going to accumulate people or accumulate money or accumulate water pouring into a jug. Do you get what I'm saying? Like you're going to actually apply it to something, accumulate distance that you've driven. All right. Today we're going to just do the topic. Next time we'll do the word problems. But I actually really like this topic. All right. So an accumulation function is given in terms of an integral. So g of x is our accumulation function. And what you have to be extra careful with is where does your accumulation start? Because if you assume it's 0, most of the time you're going to be wrong. Every once in a while they might make it 0, but where does our accumulation start? 3. It's easy to look at. Look, it's right there, 3, but it's also really easy to gloss over and not pay attention to. All right. The very first thing you're going to do is find g prime. What did I put up here before we even started this lesson? The sticky note stuff, g prime, g double prime, that's what we're going to use. So you need the derivative because it's the one that gives you all your information. Do you remember I said cite your source, kind of like a bibliography? Who's the guy that you're citing? It's the derivative. You need your derivative, all right? We literally just did this on the other side of the paper. If you do the derivative of an integral, all you're going to do is take this x, plug it in. So g prime is f of x. Listen to me. On the AP exam, and this will be there will be a free response that looks like this. It is typically worth a point to link these together. You get a point just for writing that. Link them together. And oftentimes they use G and F, to be fair. Sometimes they're different letters, but oftentimes it's G prime equals F. Link them together. It's usually worth a point all by itself if you even just write that. Okay? Now, what is this the graph of? Just read. It is the graph of f, which is g prime. This is your derivative graph. Are they going to ask you questions about g prime? No. They're going to ask you questions about g. You have to remember, you are answering questions about a graph you are not looking at. It's like I'm interviewing you about you. It's like you're asking someone questions about someone else. Okay? And we're going to justify everything, so get ready to write a little bit. Okay? How do you get a critical point? It's where the derivative equals. This is the derivative. Where does this graph equal 0? 0 and 6. Okay, your sentences should start. G of x is, or G of x has. Good job. All right. So G of x has, critical points at x equals 0 and x equals 6 because. And why'd we pick those? You picked the right answers, so just tell me why you chose those. G prime equals 0. There. My handwriting is pretty good with math symbols because I do that so much. When I start writing words and sentences, it does get a little loopy. If you can't read something I wrote, I am not at all offended. Like, please just be like, what does that say? And I will tell you what it says. Go ahead.
Is there any significance that it starts with 3?
Yes, we just didn't get to it yet.
Okay. That's where we're going to find it. Right?
Yes, good job. We're just not there yet. Okay. I know, but would you believe how many people don't understand that? Okay. State the intervals where G is increasing and decreasing. Check out your sticky note. Now we wrote F, F prime, and F double prime. Pretend it says G. G is increasing where G prime is what? Positive. That would be where this graph is above sea level. Okay, so let's write our first sentence. G of x, which is not the graph you're looking at, G of x is increasing on what interval? 0 to 6, all the way to 6. 0 to 6, because who is your source that you're citing? Yep, G prime is, and I would just say positive, but that's a personal preference. Neither of us is right, neither of us is wrong. G of x is positive there. If you say it instead of G of x, or if you say the graph instead of G of x, they are not going to give it to you. You have to say it exactly like I told you. They won't give it to you. But you hear me saying those words, you get that I'm on your side, but I'm telling you what you need to know to pass the exam. You're going to be okay. All right, now we're going to write the sibling sentence. G of x is decreasing. Yeah, you ain't even close to that. G of x is decreasing where? Negative 2 to 0. Can I go ahead and say a lot of people say negative infinity to 0? They won't give it to you. You have to stop where the interval ends, okay? Negative 2 to 0. Union 6 to 8. Perfect. Because who? G prime is negative there. Beautiful. Love it. All right, relative maximums and minimums. Maximum is a change in the derivative from what to what? Think before you answer. Maximum. Maximum is positive to negative. All right, minimum is negative to positive. All right, so let's look at our critical points, which were 0 and 6. At 0, we have a change from what to what? Good, it's below to above, so negative to positive means minimum. G of x has, that's how your sentences have to start. G of x has a relative minimum at x equals 0 because, who's your source that you're citing? G prime does what? Changes from negative to positive there. I would stick with changes. Goes is a little bit like, I mean, I would give it to you, obviously, but goes is a little bit like, I don't know, changes is more a math vocabulary word. I love to believe they would give that to you, though. Yes, and I should have said that, so thank you. Once you have linked these together somewhere on your paper, you can use them interchangeably. Okay, but I still recommend saying G prime to talk about G. Correct. So, but once you have written this once on your paper, you can then use them interchangeably as long as you've written it. Does that make sense? Only within A, B, C, and D on that same question. Yes. Yes, once you have it in your booklet somewhere, you can use them interchangeably. All right, what's going on at 6? We have a change from positive. Go ahead and see if you can write the sibling sentence. It's going to be almost the exact same thing. It starts G of x has. And we're just going to do this question verbally in case if it came up. Let's say there was a critical point that did not have a change in sign. Then your sentence would be G of x has neither relative maximum or minimum at x equals whatever because why? If you say it, they won't give it to you. G prime does not change signs there. Okay. I know that's horrible. I'm horrible. It makes me sound so hateful. I'm like the person, you write this like glorious essay for English and I'm like the person that comes behind you and corrects your grammar, but they won't give it to you. Go ahead.
So for a question that asks for the relative exterminator, like would we need to include if it doesn't either?
Correct. And normally the way they'll word that is write a statement about each critical point. So if there's 3 critical points, you should have 3 sentences. And even if one of them's neither, you would include that. But that's usually how they word that is they'll say write a sentence about every critical point. So if you read the directions, it'll be in there. Yeah. Okay. Absolute extrema. That is your candidate's test. So we're going to set up a little table, x and g of x. And I'm not looking for numbers here. Let's use vocabulary words. Who are your candidates? Endpoints and nice job. Endpoints and critical points. So there's going to be 4 of them. What's our first endpoint? All right, -2 and then 0, 6, 8. here's where that integral comes in and why it's so important that it's an accumulation function. Our accumulation starts where? 3. So for this one, we want to accumulate area from 3 to -2. Here we want to go from 3 to 0. Here we want to go from 3 to 6. And here we want to go from 3 to 8. Here's what I'm going to do because I've been talking for a while. I'm going to pause the video. And what I want you to do with your partner, the person next to you, I want you to slice this all up. And yeah, you're going to have to do some trapezoids here. Okay? No, and I have a reason why, so trust the process. Okay? I want you to slice it like I did. You're going to find the area of these triangles and trapezoids, and I'll just make sure we've all gotten the same thing. I got this. What did you get? And then I'll restart the recording. But I need to stop talking at you because, you know, attention span and all that. So I'm going to pause. We're going to find all the areas, and then we'll regroup. All right, so yeah, I got negative. Well, I got 1 for this, and I made it negative. So I got -1 for that. 7.5, 3.5, 2.5. That's 1.5. I can't fit it inside the shape, but 1.5 and then -2. Okay, cool. All right, so when we go down here to fill in our table, and I don't want to make you seasick, so I'll move the paper slowly, but you also have it in front of you. For -2, we want to accumulate from where? Where are we starting? 3. Good, perfect. From 3 to -2. So watch me point to this. No, 3 is where the problem is telling us to start. Okay, so, and sometimes I'll even tell everyone to put like an arrow there, like that's our starting place. Okay. Yeah, I know, I get that all the time. Why is it 3? And it's like, because the problem said so. And everyone forgets that that's what I said because it's such a crap answer. It's like, because the problem just said so. But that's what it says. You got to start at 3. All right, so look at, if we go from 3 backwards to -2, we're going backwards. You're starting here. You're going to go backwards to -2. That's going to make this a what? -7.5 plus 1, which would be -6.5. Good job. Perfect. For 0, you're going to accumulate from 3 to 0. Oh, good. I didn't even have to move the paper back up. -7.5. Now let me point to this one because now we're going forwards. We want to go from 3 to 6. So here's 3, here's 6. You want to go from here to here. So you're going to add up. You're going to accumulate 3.5 plus 2.5 plus 1.5. 7.5. Okay, good. I had to just double check myself there. And then 8, you're going to go from 3 to 8. Well, we just said this is 7.5 and then subtract 2. So beautiful. Your justification is the table. So you don't have to write a sentence, but you do have to state the answer. Like you don't have to put because, but you have to say which one's the biggest and which one's the smallest. So the absolute maximum, hold on, do I have white out? The absolute maximum is 7.5. Yeah, I shouldn't be writing with a pen. Is 7.5. Good. At x equals 6. Write it that way every time because sometimes they ask you for this number and sometimes they ask you for this number. And if you write it this way every time, you will always get it right. Okay. Absolute minimum is -7.5 at x equals 0. Beautiful. Cool. Inflection points. Look at your sticky note or just your note if it's not sticky. Inflection points are a change in concavity. That's concave up to concave down or vice versa. You have the first derivative graph. So that's where your first derivative changes from what to what. Or, yeah, increasing to decreasing or decreasing to increasing. There's no way around this one. I was at a seminar once where I said, hey, is there a shorter way to put this? And they said no. And I was like, okay, well, I will just be the messenger then. There's going to be a lot of them. Here we go. Have we changed from increasing to decreasing yet? No. Okay, pretend you're like on a roller coaster. Oh, here. Inflection point at 3 and where else? 4 and 5. Okay, so g of x has, you're going to make it. We're almost there. G of x has inflection points at x equals 3, x equals 4, and x equals 5. Because, and who again is your source that you're citing? G prime. Have I hammered that in enough? G prime changes from increasing to decreasing or decreasing to increasing there. And I do apologize. That is how I've been told you have to put it. But it's such an easy point to get. Do you know what I mean? Like you can tell when a graph changes from increasing to decreasing or decreasing to increasing, and you can abbreviate. So like,
So what if I spell it in this last so that you don't waste time, but if you have it, then it's.
not really. I don't think it takes that long to write. How long? I mean, we're splitting hairs. It didn't take that long to write.
What if,
Okay.
what if I spell it wrong?
Which word would you spell wrong?
Inflection.
No, I like to think they would take that. Although the word inflection is in the problem, so yes. Okay. Concave up, concave down. Look at your sticky note. Concave up, g of x is concave up when g prime is what? Increasing. So we're going to say g of x is concave up. Now let's look at our graph of g prime. Where is this graph increasing? From where to where? -2 to 3, union 4 to 5. Good. -2 to 3, union 4 to 5. Because, no, g prime is increasing there. Oh, now if you say the graph of g prime, then you're fine. I wouldn't do that, but because it's more writing. I'm lazy. I'm going to tell you the sentences in the most succinct way possible. Like if you're like, oh my gosh, this is so much. I already shortened it as best I could for you. All right. Now the sibling sentence. G of x is concave down. Good. That would be 3 to 4. I got to look back up there at my graph. 3 to 4, union 5 to 8. Not infinity. If you put infinity, they won't give it to you because the graph ends. Right? Because g prime is decreasing there. If you're one of those people that like purges your notebook every once in a while, save this piece of paper. It's kind of like a one-stop shop of everything you need to know all in one place. Now we're going to synthesize, which means put it all together. All right. We're going to draw a graph of G, that one that we've been answering all the questions about that we haven't met yet. It's kind of like we interviewed G prime and we're going to like put together what G looks like. First, let's plot some points. Oh, wow, we have a handy table full of points. Can you guys go ahead and plot those without me having to like take you through it step by step? Can we plot those? -2, -6.5, etc. All right, let's give it a shot. And then what is the last one? 8 and 5.5. Yeah, there's a lot of 0.5s because our graph, our derivative graph had a lot of triangles in and trapezoids, and those formulas involve a 1/2, and so it got choppy. At least there wasn't a semicircle, then you would have like 9 pi over 2 or something like that. So, you know, be grateful. It can always be worse. If you're doing a calculus problem and you're like, man, this is awful, it could always be worse. Always be worse. But your feelings do matter. No. Okay, now we want to put the inflection points on there too. We're almost there, guys. Hold on. Inflection points were 3, 4, and 5. Where, hold on with me for just a couple more minutes. Where did our accumulation start? 3. So if you accumulate, because I want to put these on the graph too. If you accumulate from 3 to 3, you have accumulated precisely nothing. So we can put 3, 0 on there. Now I also want 4 and 5. I want to go back and get my inflection points. So for 4, you want to accumulate from 3 to 4. So look back at your graph. And those of you that were like, why do we have to chop it up like this? This is why I had you do that. If you accumulate from 3 to 4, you get this part. 3.5. So you can plot the point 4, 3.5. Hold on, and don't connect it yet because I'm going to show you how to do that. And then we want 5. How would we get our point for 5? You're going to accumulate from 3 to 5. Good. Okay, so from 3 to 5, you're going to add these two together. 6. So you have the point 5.6. Now, when you go to connect them, you do not need to worry about increasing and decreasing. Because if you go from this point to this point, what did you do? Duh. And then to get from this one to this one, you like it's just going to happen. You don't have to worry about that. The only thing you have to worry about is concavity. So we're going to look at part F that we did here, our concavity. We're going to be concave up, so that's like a smiley face, from -2 to 3. Maybe watch me draw it and then you can draw it. So from -2 all the way to 3, we want to be concave up. Do you see how I'm making it bend upwards like a smiley face? It's the direction it bends. Also, be careful to not go below 7.5. Why not? Why can't I like come down here? That's your minimum. You can't go below that. All right. So try, and I'm not here to grade your art skills. All right. Just do your best. They're probably not going to ask you to draw something like this, but I am because I want you to put it all together. I want you to, bless you, see what's going on. All right. And then we're concave down from 3 to 4, we're concave down. So change your bend. I'm having you do this because I want you to put it all together and see what you, not graphing it to me at this point is like getting 5 feet away from the end of a marathon and then not finishing. Like, get to the finish line. Also, it helps you practice. Like, do you see how I changed the concavity? Do you see how we changed the bend in the graph? All right. And then we're concave up again from 4 to 5. So do you see how I changed the bend of the graph? And then we're concave down again. Do not go above this point. You can't go up here. This is your absolute maximum, so don't go above that.